Welcome back to the second day of the Global Webit Conference, Leaders of the Future Tech Summit. We'll begin today with the stream, the Internet of Things. Please welcome our first speaker. By founding Coursera, his goal was to give everyone access to a great education for free. Today, Coursera partners with top universities to offer online courses. With over 9 million students, it is the world's largest massive open online course platform. This time, we're going to go 100% digital by introducing to you the co-founder and chairman of the board of Coursera, Andrew Ng.
Hi. So I hope you can hear me. So by way of introduction, as you just heard, I'm the chairman and co-founder of Coursera, today the world's largest MOOC platform, and I'm also the chief scientist at Baidu. And what I thought I'd do today is share with you what we're seeing in one of the latest innovations in AI and in machine learning, which has been taking the technology world by storm. So, and I regret that I was unable to join you in Istanbul. I visited Istanbul for the first time when I was 16 years old and had loved the city. I was giving another presentation here in California just about 12 hours ago, so there was no way for me to fly out there in time. But let me share my presentation. And what I was hoping to do was share with you share with you what trends we're seeing in deep learning. So as some of you know, some of you may have heard of deep learning, which is a relatively new technology that has been taking the IT world by storm. There's also been a lot of hype about deep learning. What I hope to do in the next 15 minutes is to give you a relatively clear-eyed view of what is deep learning and what it isn't, so that when you read about it in the news, you'll be able to see through the hype, as well as for those of you that are technology leaders, that you'll be able to help your organizations strategically make decisions about whether or not this sort of technology might be useful to you. And I wasn't sure if there was some confusion earlier about whether I'm speaking about Coursera or about deep learning, but I was under the assumption that I should speak about deep learning, but I think that will be interesting to many of you. So for about 15 years now, we've had this idea of the virtuous circle of AI, in which if you build a great product, you would get a lot of users. And then if you have a lot of users, you can acquire a lot of data, be it clickstream data, user survey data, and so on. And if you have a lot of data, you can then use AI to build an even better product. But this picture has never really worked. And the missing piece was the AI piece. And that was the link of this virtuous circle of AI that has never really worked. And the reason is that if you look at most traditional learning algorithms, it turns out that even as you feed them more data, the performance of the algorithm plateaus, it flattens out, and it does not keep on getting better. And the one fundamental reason that deep learning is driving tremendous economic value to such companies as Baidu, Google, Facebook, Amazon, Netflix, and others is that insofar as any of us have been able to measure, deep learning is one class of algorithm where even as you keep feeding it more and more data, its performance just keeps on getting better. And so in the regime of big data, where companies like Baidu, Google, Netflix, Facebook, Microsoft, and so on are, deep learning algorithms are outperforming early generations of algorithms, and is allowing us to close this loop of the virtuous circle of AI. So what are deep learning algorithms? Deep learning algorithms take loose inspiration from the brain. So your brain and mine works by having huge numbers of neurons jam-packed into our skulls, and all human thought consists of these neurons passing electrical impulses to each other. So deep learning algorithms use a very, very loose simulation of the brain and simulates huge numbers of neurons in order to build intelligent in order to build AI algorithms. And so one trend that, and so several years ago, we had developed reasonably so basic deep learning algorithms, and we're trying to figure out what drives the performance of these algorithms. And we realized from experiments like these that the biggest predictor of the performance of deep learning algorithms is just how big a neural network can you build. So Adam Coates, who works with me at Stanford and now Baidu, had done experiments like these showing that the bigger you can build these neural networks, the better the performance of the algorithms. So inspired by that, several years ago, I started wandering around Silicon Valley to try to figure out who had a lot of computers that I could use in order to build giant neural networks. It turns out Google at that time had and still has a lot of computers. And so a few years ago, I started and led a project called the Google Brain Project with the goal of building really, really large neural networks. When I started the project, the largest neural networks had about 10 million connections, so about 10 million simulated connections between the neurons and the neural networks. And by doing a fair amount of pretty difficult engineering, we were able to scale this up about 2 orders of magnitude. And so using this infrastructure that my team built, one of the things I'm quite proud of is that we've been able to ship quite a lot of products. For example, if any of you use speech recognition on an Android cell phone or the Google ecosystem, its performance works much better now than it did several years ago, and you'll be using software that my team helped to build. Whilst preparing this talk, it was easier for me to find examples from Baidu, which I had joined a few months ago. I remain an active chairman at Coursera, a very active chairman, but I'm now also the chief scientist at Baidu, where we work on these technologies. And so Baidu is, of course, the largest Chinese language search engine, operates primarily in China, also Brazil, a few other countries, but speech recognition, image search, many elements of web search, like ads and so on, are all powered by these deep learning algorithms, by these neural networks at Baidu today. And one thing that all of these things have in common is these are all problems where we have tremendous amounts of data, and deep learning algorithms are incredibly efficient at soaking up these huge amounts of data and driving vastly improved performance for all of these applications. So one other fun experiment that we ran was, one thing we did was we decided to run the following experiment. We took a very large neural network, so about 1 billion parameters, and we decided to have it learn just from watching videos. So the specific experiment we did was we took this little simulated baby brain, so 1 billion connections, and so the little simulated baby brain wakes up not knowing anything, and we decided to make it watch YouTube for a week. At the end of that week, we decided to probe the neural network to try to figure out what it had learned. We had a hypothesis that it will learn to detect commonly occurring objects in YouTube videos. So we know that human faces appear frequently in YouTube videos. And so we looked and we found, lo and behold, it had found a neuron that had learned to detect human faces. So other than human faces, what else occurs in YouTube? Many people might be guessing cats. And we looked and lo and behold, it had, our neural network had created a cat neuron as well. And the remarkable thing about this was that no one had ever told it what a cat is. It had invented the concept of a cat, of this thing by itself, just by watching YouTube videos. And so building on these results, algorithms able to learn to detect objects by themselves and the various products we were shipping, I started to go around the US and Europe and Asia and give a number of presentations on the work that my team had done. But one thing I realized was that when I was leading the Google team, we were using huge numbers of computers, maybe about 16,000 CPUs in order to build some of these results. And that's just very expensive. So more recently, shortly after that, I stepped away from my Google role in order to use cheaper hardware. So it turns out that there's a piece of hardware in your computer called the graphics processor unit. You're already using this for computer graphics today. And what my team would realize was that this hardware is very, very good and relatively inexpensive. It's already in your computer for building even larger deep learning systems. And so for about 100,000 US dollars, we're able to build even larger neural networks. And that has been continuing to help us drive the performance of deep learning algorithms to the right of hand side of this graph. So earlier you heard, Internet of Things. I think that one of the reasons I'm excited about deep learning is that I think it will have a transformative effect on the internet. And two problems where deep learning is doing very well on is speech recognition and on images. So just for this last part of this presentation, let me focus just on speech and images. Baidu is the largest. Baidu is the largest Chinese language. Sorry, did someone say something to me? So Baidu is the largest Chinese language search engine, and today about 10% of our web queries come through voice search. It turns out that China is a very poor country. Half of the country works in agriculture. And so to users that are not literate, to users that don't know how to type, letting them express the information need via speech recognition is really the only way to let them communicate with a web search engine and find information. But more broadly, I think that with the whole internet moving to mobile devices, I think that no one has really figured out the good user interfaces, for our cell phones, right? That's why all of us type on these tiny little keyboards. And I would, if we can get speech recognition to be more reliable, I would love to redesign your entire cell phone's user interface around speech recognition. When you're driving in a car or taking a bus or a train, or maybe when I'm driving, even when my cell phone is sitting next to me on the passenger seat in a noisy car, I would love to be able to just talk to my cell phone and use that to send text messages to my friends or to my wife. Today, speech recognition doesn't work well enough, but if we can advance deep learning further to make speech recognition work better, even in a noisy environment, such as in a car, I think that will cause a discrete switch to the way that all of us interact with mobile devices. And I think it could transform user interfaces for mobile devices. Our investments in speech recognition is also allowing us to enter into research explorations with new designs like this. So this is not a product. This is maybe a research prototype of a music player plus alarm clock that is voice activated. So today, if you are sitting at home and you want to listen to music, you'd have to pull out your cell phone, unlock your cell phone and press a lot of buttons to get to your music player. If you have this voice-activated music player in your house, you could just speak across the room and say, Baidu Coolbox, please play some, whatever, Justin Timberlake for me, and it will play the appropriately licensed music. So I hope that someday in the future, if I have grandchildren, perhaps my grandchildren will come to me or your grandchildren will come to you and say, wow, is it really true that when you were young, you did not just talk to all of your home appliances? I think that in the future, if we can, with speech transforming mobile and speech transforming the Internet of Things, we'll have much better speech interfaces for your TV, your thermostat, your lights, and so on. And I hope that 5 years or 10 years from now, we'll look back and say that having remote controls is a crazy idea. And instead of all of us having, 3 or 4 remote controls in our homes, we should just be using much more natural interfaces like speech to communicate with our homes. So that's speech, and I think it'll be transformative for the mobile internet as well as for the Internet of Things. How about images? Let's say you're out in the field and you see flowers like these. If you want to recognize, if you don't know what these flowers are called, it's very difficult to express the shape of these flowers in a text query. But one relatively unique feature that we've developed is you can take a picture of these files and upload it to the web search engine. And so here, the web query is an image. And we can use neural networks, deep learning, to automatically recognize a picture and send you to an encyclopedia or a flower shop, depending on what we think your information need is. Or if you take a picture of the clothing, we find related clothing. If you take a picture of a handbag, And I mean, think about it, it's very hard to express the shape of a handbag in text. But if you upload a picture of a handbag, we can try to find related handbags. If you take a picture of fruit, we try to show you nutrition information. And I think just as the speech recognition has enabled us to enter into research explorations like the voice-activated music player, our investments in computer vision has enabled us to enter into research explorations like the Baidu Eye. Let me show you a video showing our vision for this. I hope the video is streaming okay. But with Baidu Eye, a wearable device, we think that if you, want to recognize an object, an insect, or if you're at a museum and you want to ask what picture is this, then we can use computer vision, deep learning, and neural networks to recognize the picture. And the lady is wearing a headset with headphones in her left ear, so you can speak to her left ear to tell her more information about a picture, or in this case, give her directions to a store. And then if she sees a handbag that she's considering purchasing, she can ask the system, and then it will whisper additional information into her ear to give her more information about, say, the handbag that she's seeing. Compared to other smart glass designs like Google Glass and others, Baidu Eye, the hardware is different. We didn't want to put a lens in front of your eye, but more importantly, what the real differentiator for Baidu Eye relative to the various smart glass designs is the software. The thing that powers Baidu Eye isn't the hardware so much. I think the hardware works just fine, but the secret ingredient, or really the thing that works really well, was our focused investment on deep learning algorithms and on computer vision technology to help Baidu Eye better understand what you're seeing so they can augment human perception and provide additional information. Just to finish up, I think that so much of the internet is about speech, images, as well as text, which I didn't talk about. But deep learning today is proving to be a key technology for helping computers understand speech, images, and text. At Baidu, we think that within 5 years, 50% of our web search queries will be speech and images. And so deep learning AI algorithms are a key technology for us to understand all of these forms of data and to help us to serve users better. So I'm excited about the future of deep learning. I think that whoever figures out deep learning, whoever figures out AI, will be in, frankly, the best possible position to develop technologies to recognize speech, images, and text to develop better products and services for users. And so with that, and I think deep learning will be transformative for mobile internet, for the Internet of Things, and hopefully help us create many new services for users. And with that, let me say thank you all very much.
Andrew, can you hear us?
Yes, I can.
Yeah, we really want to thank you. By the way, where are you now? In California, or you're based?
Yes, I'm speaking with you from California, where it is 1:15 a.m. So it's middle of the night.
We want to thank you for joining, even it's midnight there. Hey, everyone, say good night to Andrew, because he's going to sleep now. Well deserved. Thank you for joining. Hope to see you someday, maybe in person. Next year, you're always invited at Webit. Hey, wave to Andrew.
Thank you.